I want to continue in this video with a few more examples of writing equations. So I want to focus first on vertical and horizontal because we haven't talked about that yet. So for instance, find an equation for a vertical line through the point, how about -3, 6? Okay. So a few things to remember, a vertical line, those are the ones that go straight up and down. They always have equations that look like x equals some number. So that's the form that they're in. There's no y variable there. Alternatively, a horizontal line, those are the ones that go left to right, have the equation of y equals a number. So the slope here is, so for these ones, remember the slope is 0. So they do kind of look like a standard equation, but with a 0 slope there. So there's a couple of ways that you can think of this. So one thing you could do if it helps you to visualize, you could draw a picture. So 1, 2, 3, 1, 2, 3, 4, 5, 6. I'm just doing a really rough picture here. So here's the point -3, 6. So a vertical line would just go through it right like this. So if you look at that vertical line, you can see that the x value is always remaining at -3, right? It's not changing from -3. So to write an equation here is actually really quick. You're just going to write x equals -3. So you use the value in the point there. And you just have to recognize the form. Vertical lines are always x equals. So you use whatever x value is there. Now I could also write have the question of, well, what would be the horizontal equation? Again, I know it's going to be y equals some number. So if I look at this point, it was 6. So our equation there would be y equals 6. So you can write vertical and horizontal equations very, very quickly. You don't have to go through the full process that we do in most cases. So these are a little bit more of exceptions. Let's do another example. Find an equation of the line parallel to y equals 5 and passing through -2, 3. Now you want to remember here that parallel means the same slope, right? So if you see a question that says parallel, you want to think, hey, this has got to be the same slope as the other line. Well, in this case, the other line is y equals 5. This is a horizontal line. So I know my slope here is 0. As a little side note here, you could also do this for vertical, but just remember your slope is undefined. So if it's parallel to something vertical, it means that both lines have undefined slope instead. So here, your slope is going to be the same as this one, right? It's going to stay 0. So my slope is going to stay 0, which means that I must have another horizontal line. So the equation is going to be y equals some number. In this case, my value is c, so the solution is just y equals 3. So remember, parallel is same slope. So if it's horizontal, it's going to stay horizontal. If it's vertical, it's going to stay vertical. So it's going to stay the same style. I could also do something perpendicular. Let's do the same question, but perpendicular. And I want you to remember that perpendicular is not parallel, right? Perpendicular, these slopes are opposites, right? So these are your perfect opposites. They are the negative reciprocal, so they're opposites. Now, notice here that we have, it's perpendicular to y equals 5, which is a horizontal line. Now, in case this wasn't obvious. Horizontal and vertical lines are perpendicular to each other. Because if you think about a slope of 0, if you try to flip that, you get something undefined, right? So the way it works is that a 0 slope and an undefined slope are opposites. So normally we would take something, we would flip the slope, we would change the sign. That's what we're looking for perpendicular. For vertical and horizontal lines, those two together are perpendicular. They're opposite of each other. One line goes like this, one line goes like this, and you get this nice 90-degree angle. So in this case, because I'm going perpendicular, instead of a horizontal line, I am going to use a vertical line. So my equation is going to be x equals some number. You see there. And my x value is -2. So a perpendicular line would be x equals -2. So the big takeaway here, and again, you can do a lot more with parallel and perpendicular here. We actually can do them with full, regular equations too. But kind of staying with that vertical and horizontal idea, if you have a parallel question, if it's horizontal, it stays horizontal. If it's vertical, it stays vertical. If the question though changes to perpendicular, and again, you're comparing it to either a horizontal or vertical line only, then you would use the opposite. If it starts horizontal, it becomes vertical. If it starts vertical, it becomes horizontal. And like I said, there are more complicated parallel and perpendicular examples here. So this just focuses on when you're working strictly with vertical and horizontal lines. That's how those would work. Okay, one last example I want to do in this video is a little bit different than the last ones we just did. So I'm going to go away from vertical and horizontal for a minute and look at a word problem. So we can take word problems and also write equations. So if you need to pause the video here to write the equation or the question down, please do. Otherwise, when you're ready, let's go ahead and read. It says a web-based t-shirt company has learned that by pricing a clearance t-shirt at $6, the sales will reach 2,000 t-shirts a day. Raising the price to $8 will cause a sale to fall to 1,500 shirts per day. So perhaps this company has been just, monitoring their sales, and they're noticing this trend that when, the t-shirts are $6, they tend to sell around 2,000 t-shirts. But when this t-shirt prices are $8, not as many people buy them. They only sell around 1,500 shirts per day. We're going to assume the relationship is linear. So between sale price and t-shirts, which is not always the case, right? It could be a different model, but we're going to assume it's a linear model here, so it's consistent. And we're going to write an equation that describes this relationship. And then we're going to predict t-shirt sale if the price were to change to $7.50. So the first thing I need to do is figure out that I actually have points here. So remember, when you're writing an equation, right? So for part A, anytime you have to write an equation, unless it's a vertical or horizontal line, those are the exceptions because those are pretty quick. You need a slope and a point. So I don't have any just yet, but I can find them. So if I read through again, I see this pairing here of $6 going with 2,000 shirts per day, whereas $8 matches with 1,500 shirts per day. These are paired, right? So actually, these are my points. My first point that I have is that when the price is $6, I sell 2,000 shirts. And the second is when the price is $8, I sell 1,500 shirts. So I do want to note here that I'm using for X, the price in dollars. And the Y value I'm considering here is the number of t-shirts, right? The number of tees sold. Now, this is just one way to set it up, but I'm going to set it up this way. So I'm going to compare price with number of t-shirts sold here. And then using these 2 points, I actually can find my slope now. So I can do my y2 minus y1 over x2 minus x1 formula. So I'm just going to use this as my 2 point. So it's going to be 1,500 minus 2,000 over 8 minus 6. So I have -500 over 2, which is -250. So that's my slope. And again, I could use any point I want here. It really doesn't matter which one you want. I'm going to stick with 6, 2,000, but you could also do 8, 1,500. Now, the point that I have, again, is not the y-intercept, right? The y-intercept is the easy one. If it's not the y-intercept, what I'm going to use instead is the y minus y1 equals m times x minus x1. So here, my Y1 is going to be 2,000. My M is negative 250, and my X1 is 6. So I'm going to clean this up a little bit. I'm going to multiply this through. So I have negative 250x. Here, my two negatives will become a positive, and I have 1,500. I'm going to add the 2,000 to both sides. And I have y equals negative 250x plus 3,500. Now I'm going to go ahead and just leave this one in this form. Or it would make it really easy if I wanted to graph this. I can see that slope or rate of change right there. So I can see that the number of t-shirts are, decreasing as we change the X values in a positive direction there. So that would be my equation. Now, the second thing I'm going to do is I'm going to go ahead and predict what happens when my price is 750. So the key thing I need to know here is that I did let price be X. So that means I'm going to let X be 750. And I'm just going to go ahead and plug this into my equation. And you're going to go ahead and you're just going to use your calculator here. You get negative 1875 for the first piece. And when I add that in, I do get 1625 here. So when the price is $750 per shirt, the sales are $1625. So if we can see patterns, right, that our sales change linearly based on how we change the price, they can kind of help us figure out, the best price to set it at. Now, this is something extra to think about. So let's actually think about what's happening here. So when we had $6 per t-shirt, we sold 2,000 of them. So that would have been sales of $12,000. When our price was $8, we sold 1,500. So actually, it's also sales of 12,000 t-shirts. So sorry, $12,000. So we're staying at the same piece here. And then our last one, 750 times that 1625, we actually see a slight change in the amount of revenue coming in. I know it's a little hard to see on see if I can get this too. That's a little better. So when we have $6 shirts and we sell 2,000 of them, we bring in $12,000 revenue. When I change the price to $8, even though I'm only selling 1,500, I'm still actually bringing in $12,000 revenue because though the increase in price had us offset the decrease in number of shirts. We can see that 750 actually looks like a better deal here, right? When I sell, theoretically, if my price was 750, I would probably sell around 1,625 shirts. So I'm actually getting a little bit over $12,000 profit. So I'm kind of touching on the idea of trying to find, those peak prices that we can use here, or that peak revenue. So there's a lot more math that you can do with these examples, which are really fun, particularly with more complicated data. And we can actually kind of think about optimizing our results. So, where should our price point be, right? So maybe it should be $9, maybe it should be $5, maybe it should be $7. I don't know yet, right? Based on the data. But as you get into more complicated data, it's really fun to actually kind of research and think about, well, where is that ideal price point where you're balancing cost to the consumer and also sales so that you're bringing in the most revenue possible. And again, that also does come down to things like supply and demand as well. So just a little bit of introduction there and taking this, much further than was asked. But it's just kind of fun to delve into these a little bit more, particularly as they get more complicated in business and think about, where is that ideal price point when starting a company.